Welcome everyone! Thank you for being here. Today I'm going to show you something that I wish existed when I started building cross-platform applications. It's called the Cross-Platform Monorepo Template, and its promise is simple. Take you from an empty directory to a production-ready web and mobile app with real features, real authentication, real-time data, and AI built in. Now, whether you're a product manager trying to understand how your engineering team can ship faster, or a developer who's tired of reinventing the wheel every time you start a new project, this presentation is for you. We'll cover the why, the what, and the how. And by the end, you'll have a clear picture of how a single code base can power both a web app and a mobile app without compromise. Let's dive in. So let's start with the problem. And I mean the real problem, the one that costs teams months. Pain point number one, duplicate code bases. You build your web app, then you build your mobile app, and now you have two versions of the same business logic, two authentication flows, two sets of API calls, and they slowly drift apart. Bug fixed on web, probably still broken on mobile. Pain point number two, integration chaos. You pick a backend, you pick an auth provider, you pick a UI framework, and then you spend weeks, sometimes months, just getting them to talk to each other. TypeScript types don't match, auth tokens don't flow correctly, real-time sync breaks on one platform but works on the other. And pain point number three, maybe the worst one, there's no clear path. No one tells you what to build first. Do you start with auth, with the database, with the web app, or the mobile app? Every team figures it out differently, and most teams figure it out painfully. These three problems are what we set out to solve. Here's our answer: one template, zero compromise. The key insight is this: share the backend, share authentication, share your types, share your content, but let each platform have its own native UI. For the business folks in the room, what this means is your team writes the important stuff once. The business logic, the data model, the security rules, the AI features, all of that lives in one place. When you fix a bug or add a feature to the backend, both platforms get it instantly. That's not just faster development, that's fewer bugs, lower maintenance cost, and a more consistent user experience. For the developers, the architecture is a Pentium Workspace's monorepo managed by TurboRepo. Shared packages export TypeScript types, utility functions, constants, and content. The web app is React with Vite. The mobile app is Expo with React Native. Same imports, same backend calls, completely different rendering. The UI stays native, the logic stays shared, that's the deal. Now, a template is only useful if it's real, and by real, I mean it includes features that actual production apps need. So here's what's in the box. 8 features, fully implemented on both platforms: real-time chat with live messages and emoji reactions, an AI chatbot powered by Claude Haiku 4.5 with streaming responses, full authentication with Clerk, sign up, sign in, protected routes, interactive diagrams, user profiles with avatar uploads, dark mode that works everywhere, a 3-layer error boundary system so your app doesn't just crash when something goes wrong, and a complete CI/CD pipeline that tests, lints, builds, and audits your code on every push. This isn't a to-do app, this is a real production-grade application that you can clone, customize, and ship. Let me show you how it all fits together. Let's talk about the technology choices and, more importantly, why we picked each one. At the build layer, we're using TurboRepo version 2.8. For the non-technical folks, TurboRepo is what lets us manage all of our code in one place while still building each piece independently. It's the traffic controller for our monorepo. On the web side, React 1.9.1, Vite 7.2 for blazing fast builds, TanStack Router 1.158 for type-safe file-based routing, and Tailwind CSS version 4.1 for styling. On the mobile side, Expo SDK 54 and React Native 0.81. Expo gives us a managed workflow, no Xcode headaches, no Android Studio nightmares. For the backend, Convex 1.32. This is our real-time database and serverless function platform. Think of it as your entire backend in a box: database, API, and real-time subscriptions, all with TypeScript end-to-end. For AI, Claude Haiku 4.5, fast, capable, and cost-effective. For auth, Clerk, versions 5.49 on web and 2.15 on mobile. And everything is written in TypeScript 5.9, with ESLint 9 enforcing code quality. Every single one of these choices was made because it reduces complexity and increases developer velocity. That's the filter. Now let's look at how the code is actually organized. At the top level, we have a monorepo, a single repository that contains everything. Inside, there are 2 main directories. First, apps. This is where the platform-specific code lives. App/web is the React web application built with Vite and Tailwind. App/mobile is the Expo React native application. Each app has its own configuration, its own UI components, its own routing. They look and feel native to their platform. Second, packages. This is the shared layer. Packages/shared contains the TypeScript types, utility functions, constants, and content data that both apps consume. Packages/backend contains all the convex server functions, the mutations, queries, and actions that power the real-time backend. Packages/assets holds shared images and static files, and packages/config holds shared ESLint and TypeScript configuration. For the product folks, this means every feature we build in the shared layer is automatically available to both platforms. We don't build it twice. We build it once and render it twice. For the developers, this is standard PNPM workspaces. Each package has its own package.json, its own build step, and its own exports. Turborepo handles the dependency graph and parallel builds. This slide is the architectural thesis of the whole project. Share logic, not UI. Let me explain what that means in practice. The @repo/shared package exports things like type definitions. What does a user look like? What does a message contain? Both apps import the same type, so they can never disagree about the shape of the data. It also exports utility functions. For example, we have a group reactions function that takes an array of emoji reactions and groups them by emoji with a count. The web app calls that function. The mobile app calls that exact same function. Same logic, same output. But here's what we don't share. The UI rendering. The web app renders a hover bar for adding emoji reactions. You mouse over a message and a little toolbar appears. The mobile app renders a long press menu. You hold your finger on a message and a sheet slides up. Same data, same logic, completely different user experience, because web users and mobile users interact differently. This is the key to cross-platform done right. You're not forcing a web paradigm onto mobile. You're not fighting against the platform. You're embracing each platform's strengths while keeping your business logic in one place. Let's go deeper on the back end. We're using Convex, and I want to explain why this matters. For the non-technical audience, Convex is a backend that gives us real-time updates out of the box. When someone sends a chat message, every connected user sees it instantly. No refresh, no polling, no complicated setup. It just works. The entire backend schema is 4 tables. That's it. 4 tables power the whole application. Table 1, Users, stores the clerk ID, the user's name and image URL from clerk, plus optional custom name and custom image URL for profile customization. Table 2, Messages. Each message has a URD, a body, and an array of reactions, each reaction being an emoji and the user who reacted. Table 3, Presence, tracks which users are online in which rooms, using a clerk ID, a roomd, and a last seen timestamp. Table 4, Chat Rate Limits. This is the token bucket for AI chatbot rate limiting. Stores a key, a token count, and a last refill timestamp. For the developers, Convex gives us end-to-end TypeScript types generated from this schema. When you write a query or mutation, the argument validation and return types are all inferred. And every query is a live subscription by default. The UI re-renders automatically when the underlying data changes. No WebSocket plumbing required. Authentication is one of those things that seems simple, but is actually a minefield. We use Clerk, and more importantly, we use Clerk the right way for a cross-platform setup. Here's the flow. A user signs in through Clerk, whether that's on the web app or the mobile app. Clerk issues a JWT, a JSON web token that proves who the user is. That JWT gets sent to Convex with every request. Convex verifies the token, extracts the user identity, and authorizes the operation. The beautiful part, it's the same Clerk application for both platforms. One set of users, one authentication configuration, one security model. A user who signs up on web can sign in on mobile and see all their data. Now for the developers, there's an important nuance here. We pin Clerk to specific versions, 5.49.0 on web, 2.15.0 on mobile. Why? Because these are the last versions where the React peer dependency is listed as *19.0.0. Later versions tightened that constraint in ways that conflict with Expo SDK 54's React pinning. This is exactly the kind of gotcha that costs teams days of debugging. We've already solved it for you. Introduce a mental model that makes this whole architecture easier to remember. We call it N3Utron, and it maps the technical architecture to a human body. Why a body? Because bodies are systems of specialized parts that work together. Your brain doesn't try to be your heart. Your legs don't try to be your arms. Each part has a job, and the whole system works because each part does its job well. That's exactly how a well-architected application should work. The AI layer doesn't try to be the database layer. The infrastructure doesn't try to be the user interface. Each component has clear boundaries and a clear purpose. For the non-technical audience, this metaphor gives you a vocabulary to talk about the system. When someone says we need to improve the brain, you know they're talking about AI capabilities. When they say the heart needs attention, that's the real-time data layer. For the developers, don't worry, I'm not suggesting you put this in your technical documentation, but I am suggesting that having a shared mental model helps teams communicate, especially when half the team isn't writing code. Let me break down each body part. 6 body parts, 6 capabilities. The brain, that's our AI layer. Claude Haiku 4.5 with streaming, tool use, per-user conversation threads, and rate limiting. The brain thinks, reasons, and responds. The heart, that's the real-time engine. Convex live queries, presence tracking, instant message delivery. The heart keeps data flowing to every connected client without missing a beat. The core, the database. Our 4-table schema, server-side validation, type-safe queries, and mutations. The core stores and protects the data. The arms, integrations. Clerk for authentication, file uploads via convex storage, third-party API connections. The arms reach out and interact with external services. The legs, infrastructure. Turbo repo builds, Vercel deployment, EAS builds for mobile, CI/CD pipelines. The legs carry everything and keep it moving forward. And the carry-on, that's the portable agent. The patterns and architecture that travel with you from project to project. The knowledge of how to build this kind of system. Each part is independently valuable. Together they form a complete functioning application. Let's zoom into the brain, the AI chatbot. Because this isn't just call an API and display text. This is a properly engineered AI feature. Here's the flow. A user sends a message. First, it hits the rate limiter. We use token bucket rate limiting, not fixed window. Why does that matter? Because fixed window rate limiting has a burst exploit at the boundary. A user could send their limit at 11 hours, 59 minutes, and 59 seconds, and again at 12 hours, 0 minutes, and 0 seconds, effectively doubling their rate. Token bucket prevents that. Authenticated users get 10 requests per minute. Guests get 5. The @mention feature where you tag the bot in chat gets 3 per minute because those responses are visible to everyone. After rate limiting, the system manages per-user conversation threads. Each user has their own context. Then the message goes to Claude Haiku 4.5, which has access to 5 tools: get my profile, get my messages, get my presence status, send chat message, and get capabilities. But here's the security detail. Guest users only get access to 1 tool, get capabilities. Authenticated users get all 5. We maintain 2 separate tool maps to enforce this. Responses are streamed back in real time, and the bot can operate in 2 modes: a private widget for one-on-one conversations, or an @mention in the public chat where the response is visible to all users. This is production-grade AI integration, not a demo. Let's shift from architecture to features, and we'll start with the centerpiece, real-time chat. For the non-technical audience, real-time means instant. When someone sends a message, you see it appear on your screen the moment it's sent. No refresh button, no delay. It's the experience you expect from any modern messaging app, and it works the same way on both web and mobile. We've got live message delivery, emoji reactions on every message, and presence tracking. You can see who's online right now. These 3 features together create a sense of liveness, of being in a shared space with other people. That's what turns an app from a tool into an experience. For the developers, this is all powered by Convex Live Queries. When you call useQuery for a list of messages, Convex doesn't just fetch them once. It opens a persistent subscription. Anytime the messages table changes, new message, new reaction, deleted message, your component automatically re-renders with the fresh data. There's no WebSocket setup, no pub// configuration, no cache and validation logic. You write what looks like a normal database query, and you get real-time reactivity for free. And because the query functions live in packages/backend, both the web and mobile apps call the exact same server code. Let me zoom into emoji reactions because they're a perfect example of the share logic, not UI principle in action. On the web, when you hover over a message, a small reaction bar appears. You can click an emoji to add your reaction. It's a hover interaction because that's natural on desktop with a mouse. On mobile, you long press a message and a sheet slides up from the bottom with emoji options. That's the natural gesture on a touchscreen. 2 completely different UI patterns, 2 completely different interaction models. But underneath, the exact same utility function. The group reactions function lives in at repo/shared. It takes the raw array of reactions, Each one is an emoji string and a user ID, and groups them. 3 people reacted with thumbs up, 2 with heart, 1 with fire. Both platforms import this function and use its output to render their respective UI. For product teams, this means behavior is guaranteed to be consistent. If there's a bug in how reactions are counted, you fix it once and both platforms are fixed. For developers, this is the pattern you'll repeat for every feature. Put the logic in shared, put the UI in the app. It's simple, but it's powerful when you do it consistently. Dark mode. It sounds trivial. It is not trivial. Getting dark mode right across 2 platforms with different styling systems is one of those problems that quietly eats a week of engineering time, so we solved it properly. On the web, the user's preference is stored in local tense. The implementation uses Tailwind CSS's dark variant. You write dark.byg-gray 900, and the class applies when dark mode is active. A class is toggled on the HTML element, and Tailwind handles the rest. On mobile, it's a different world. There's no Tailwind. The preference is stored in Secure Store, Expo's encrypted storage API. The styling uses a color token system, a set of named colors that swap between light and dark palettes based on the current mode. Different storage mechanisms, different styling approaches, but the user experience is the same. You toggle dark mode and the entire app transforms. For the product audience, dark mode isn't a nice-to-have anymore. It's expected. Users want it, and some users need it for accessibility. Having it built into the template from day one means you never have to retrofit it later, and if you've ever tried to add dark mode to an existing app, you know that's a nightmare. It works on both platforms. Out of the box, profiles and avatar uploads. This feature showcases an important architectural pattern. Users can set a custom display name and upload a profile photo. Standard stuff. But the implementation has a subtlety that's worth understanding. Convex has a 1 megabyte limit on mutation arguments. An image file easily exceeds that. So we use a 2-step upload pattern. Step 1, the client calls generate upload URL, which returns a short-lived pre-signed URL. Step 2, the client uploads the raw image bytes directly to that URL via an HTTP put. This bypasses the mutation size limit entirely because it's a direct storage upload. Step 3, the client receives a storage ID back and passes that just a small string to a mutation that links the uploaded image to the user's profile. For the non-technical folks, the key takeaway is that file uploads work reliably on both web and mobile, and they work with files of reasonable size. Your users can upload real photos, not just tiny thumbnails. For the developers, this pattern is reusable for any file upload scenario in Convex. Documents, images, audio files. Same 3-step flow. The template gives you a working implementation you can copy for any upload feature. This is one of my favorite features in the template, and honestly, it's the one most teams skip until it's too late. 3-layer error recovery. Here's the reality. Your app will crash. Not might, will. A network request will fail. A component will receive unexpected data. A third-party library will throw. The question isn't whether it happens, it's what the user sees when it does. Layer 1, the app-level error boundary. This wraps the entire application. If something catastrophic happens, the CSS fails to load, the router breaks, React itself throws, this boundary catches it and shows a user-friendly error screen. Now here's a critical technical detail. This top-level boundary uses inline CSS, not Tailwind. Why? Because it wraps the CSS pipeline itself. If Tailwind fails to load, Tailwind classes won't work. So the error boundary that catches CSS failures cannot depend on CSS, inline styles only. Layer 2, component-level error boundaries at the page and feature level. These use Tailwind because the CSS pipeline is already loaded at this point. If the chat component crashes, the rest of the app stays functional. Layer 3, content-level fallbacks. If a piece of content can't render, you see a sensible default instead of a blank space. And yes, error boundaries in React must be class components. There is no hook equivalent for combinatic catch. That's a React limitation, not a choice. The template handles it correctly. Security, not as an afterthought, not as a checklist before launch. Security by design. There are 4 layers of security built into this template from the start. First, input validation. Every mutation and action in Convex validates its arguments using a schema. Bad data doesn't even reach your business logic, it's rejected at the door. Second, rate limiting. We already talked about the token bucket algorithm for the AI chatbot, but the principle extends everywhere. We protect expensive operations from abuse. Third, security headers. The web deployment includes proper HTTP security headers, content security policy, X-frame options, and others that protect against common web attacks like cross-site scripting and clickjacking. Fourth, static analysis. ESLint 9 with security-focused rules catches potential vulnerabilities at development time before the code ever reaches production. For the executive audience, this matters because security breaches are expensive, not just in terms of data loss, but in user trust, legal liability, and reputation. Starting with a secure foundation is dramatically cheaper than bolting security on after the fact. For developers, every pattern here is extensible. The validation schemas, the rate-limiting utilities, the header configuration, they're all there for you to build on. All right, let's talk about the pipeline that keeps everything honest. Every time you push code, this happens automatically. First, TypeScript types are checked across the entire monorepo. If your shared types changed and broke something in the web app, you know immediately. Then linting. ESLint 9 runs across all packages. Then the build step. Both apps compile. Then tests. Then a security audit of your dependencies. And running alongside all of this, Dependabot. It monitors your dependencies for known vulnerabilities and automatically opens pull requests to upgrade them. For the business audience, what this means is that code quality is enforced automatically. It doesn't depend on whether someone remembered to run the tests. It doesn't depend on code review catching a typo. The machine checks every single push, every single time. That's consistency you can't get from process alone. For developers, this is a GitHub Actions workflow. The pipeline uses TurboRepo's dependency graph to run tasks in the right order, types first, then lint and build in parallel, then tests. It's fast because TurboRepo caches build artifacts and only rebuilds what changed. Deployment. 3 targets, 1 command each, but the order matters. Target 1, convex. The backend deploys first because both apps depend on it. If you deploy a new web app that calls a backend function that doesn't exist yet, everything breaks. Backend first, always. Target 2, Vercel. The web app deploys to Vercel's edge network. Fast, global, automatic HTTPS, preview deployments on every pull request. Target 3, EAS, Expo Application Services. The mobile app builds in the cloud and can be distributed to testers or submitted to the App Store and Google Play. No local Xcode or Android SDK required. The key insight is the dependency order. Convex, then Vercel, then EAS. Deploy in dependency order means the backend is ready before any client tries to use it. For product teams, this means deployment is predictable. It's not a scary event. It's a routine operation with a clear, repeatable process. Each deploy is independent. If the mobile build fails, the web and backend are already live and working. For developers, each deployment target has its own environment variable configuration. The template includes documentation on exactly what needs to be set where. Now we arrive at what I think is the most valuable part of this entire project. Not the code, not the architecture, the process. We call it Do Me, and it's our 17-phase build process. The tagline is, not just what to build, but why in that order. Look, you can find 100 tutorials on how to set up React, or how to configure Expo, or how to use Convex. What you cannot easily find is a guide that tells you, here's the exact sequence of steps to go from nothing to a production-ready cross-platform app, and here is why each step comes before the next one. Do Me is that guide, 17 phases, each one building on the last. Each phase has a clear entry condition, what must be true before you start, and a clear exit condition, what must be true before you move on. For the product audience, this is your project plan. When someone asks how long until we have auth working, you can point to phase 4. When they ask when can we deploy, you can point to phase 8. It makes the build process legible to everyone on the team, not just the developers. For the developers, this is battle-tested ordering. We built it this way because we tried other orderings and they failed. The sequence encodes hard-won lessons about dependency chains, integration points, and verification gates. Let's walk through the phases. The foundation, phases 1 through 4. Phase 1, Monorepo setup. This is where you create the repository, configure PNTM workspaces, set up TurboRepo, and establish the project structure. Apps directory, packages directory, root configuration, nothing runs yet, but everything has a place. Phase 2, shared packages. You create @repo/shared with your TypeScript types, utility functions, and constants. You set up @repo/backend as the convex package. You create @repo/config for shared ESLint and TypeScript configuration. Why shared packages before the apps? Because when you build the apps in phases 5 and 6, you want to import from shared immediately. You don't want to go back later and refactor local types into shared types. Start shared, stay shared. Phase 3, convex backend. You define your schema, those 4 tables, and write your first queries and mutations. You deploy the backend to Convex's cloud. Now you have a live real-time backend with no app to connect to yet. And that's fine. You can test it with the Convex dashboard. Phase 4, clerk authentication. You configure Clerk, set up the JW2 integration with Convex, and test the auth flow. At the end of Phase 4, you have a deployed backend and working authentication. The foundation is solid. Phases 5 through 7. Now we build the apps. Phase 5. Web app first. React, Vite, TanStack Router, Tailwind CSS v4. You connect to Convex, connect to Clerk, and render your first authenticated page that reads live data from the backend. Why web first? 2 reasons. First, the development feedback loop is faster. Hot module reload, browser dev tools, no simulator needed. Second, web has fewer platform constraints. You're not fighting with Metro bundler configuration or native module linking. Get it working on web, then bring it to mobile. Phase 6 mobile app, Expo SDK 54, React Native 0.81. You set up the project, configure Metro, and this is where the React pinning matters. React must be pinned to 19.1.0 in pntmem.overrides because Expo SDK 54 requires a specific version. Without that pin, you get duplicate React instances and nothing works. Phase 7, protected screens and the skip pattern. This is where you implement authenticated routes and learn one of the most important patterns in the template. The skip pattern, use query with the API function and, crucially, a conditional argument. If the user is signed in, pass the real arguments. If not, pass the string skip. This tells Convex to skip the query entirely, preventing stale state from a previous session from flashing on screen during remount. This one pattern prevents an entire class of auth-related bugs. Phases 8 and 9. Deploy and verify. Phase 8 is deployment, and you might think it's early. We haven't built any features yet. That's the point. You deploy before features for a critical reason. If deployment is broken, you want to know now, not after you've spent 3 weeks building features that you can't ship. Deploy early. Deploy often. Deployment is not the last step, it's a continuous practice. So in Phase 8, you deploy the Convex backend, push the web app to Vercel, and configure EAS for mobile builds. 3 targets, dependency order, just like we discussed. Phase 9 is full verification. You don't just check that the deployment succeeded, you verify the entire flow. Sign up a new user on web, sign in on mobile, verify the data shows up on both. Test the real-time sync, send a message on one device, see it appear on the other. Check that auth tokens are flowing correctly. For the project managers, this is your first major milestone. At the end of Phase 9, you have a deployed, authenticated, real-time cross-platform application. It doesn't have features yet, but it works. The skeleton is standing and it's alive. Everything from here on is building on a proven foundation. Now the fun part, features. Phases 10 through 13. Phase 10, content data. This is where the shared content system goes in. Content that's defined once in at repo/shared and rendered on both platforms. This establishes the pattern for all content-driven features. Define it in the shared package. Render it in the app. Phase 11, body diagrams. The interactive explorable architecture visualization, our N3 Utron body metaphor as an actual interactive component. This showcases SVG rendering on web and a custom implementation on mobile. Phase 12, AI chatbot. Claude Haiku 4.5 integration with all 5 tools, 2 tool maps for authenticated and guest users, streaming responses, per user threads, and the token bucket rate limiter. This is a substantial phase because the AI system touches off the database and the real-time layer. Phase 13, profiles. Custom display names, avatar uploads with the 2-step pattern, and profile cards that update in real time across both platforms. Notice the ordering. Content before AI chatbot. Why? Because the chatbot uses the GEP capabilities tool to describe what the app can do, and that data comes from the content system. Dependencies flow forward, never backward. For the team, at the end of Phase 13, you have a fully featured application. Everything from here is hardening. Hardening. Phases 14 through 16. This is where the application goes from it works to it's ready for real users. Phase 14, error boundaries. The 3-layer system we discussed earlier. App level with inline CSS, component level with Tailwind, and content level fallbacks. You implement these after the features are built because you need to know what can fail before you build the recovery. Phase 15, security. Input validation hardening across all mutations. Rate limiting on expensive operations. Security headers on the web deployment, static analysis rules in ESLint. You go through every endpoint, every mutation, every user-facing input, and make sure it's locked down. Phase 16, CI/CD. The GitHub Actions pipeline. Type checking, linting, building, testing, auditing. Dependabot configuration. Branch protection rules. For the executives, phases 14 through 16 are the difference between a demo and a product. Any team can build a demo that works when you use it correctly. A product works when you use it incorrectly, when the network drops, when someone tries something unexpected. That resilience is what these 3 phases deliver. For developers, these phases also produce reusable patterns. The error boundary implementation, the rate-limiting utility, the CI pipeline, you'll copy these to every future project. Phase 17, Final Verification, the Production Readiness Checklist. This is a comprehensive, systematic review of the entire application, not a quick smoke test, a thorough walkthrough. You test every feature on both platforms. You test auth flows, sign up, sign in, sign out, token refresh. You test error scenarios. What happens when the network drops, when the backend is slow, when invalid data is submitted. You test the AI chatbot as both an authenticated user and a guest. You verify rate-limiting works. You check security headers. You review the CI pipeline. For the whole team, Phase 17 is your gate to production. When this checklist is complete and everything passes, you have confidence that the application is ready for real users, not hope. Confidence. And that completes the DOMI process. 17 phases, from empty directory to production-ready cross-platform application, with every decision documented and every ordering justified. All right, enough theory. Let's talk about how you actually use this thing. 5 minutes. That's the honest estimate. Here's what you do. Step 1, clone the repository. 1 git clone command. Step 2, install dependencies. Run pnpm install at the root. Because this is a pnpm workspace, that single command installs dependencies for the web app, the mobile app, and every shared package. Step 3, configure your services. Create a Convex project. Create a Clerk application. Get your Claude API key. Each service has a free tier, so you don't need a credit card to get started. Step 4, set your environment variables. The template includes an nvev.example file that lists every variable you need. Copy it, fill in your keys, and you're configured. Step 5, run pntm dev. Turbo Repo starts the Convex backend, the web dev server, and the Expo development server, all in parallel, all from one command. Open your browser and you'll see the web app. Open Expo Go on your phone and scan the QR code for the mobile app. Both are connected to the same backend, the same auth, the same real-time data. For the decision makers in the room, 5 minutes from clone to running application. That's the developer experience we're providing. No week-long setup sprint, no integration marathon. 5 minutes. Now, a template is only useful if you can customize it. So let me walk you through the extension points. Want to add a new page? Add a root file in the web app's roots directory. TanStack router picks it up automatically via file-based routing. Add a corresponding screen in the mobile app's navigation. Both point to the same backend data. Want to add shared business logic? Create a new file in packages/shared. Export your types, your utility functions, your constants. Both apps can import them immediately. The workspace linking handles it. Want to add a new backend feature? Write a new query or mutation in packages/backend. Convex generates the TypeScript types automatically. Your IDE auto-completes the function name and its arguments from both apps. Want to add an entirely new shared package? Create a new directory under packages, add a package.json comma, and reference it in the other packages or apps that need it. TurboRepo sees the new node in the dependency graph and incorporates it automatically. For the non-technical audience, the message here is that this template isn't rigid. It's a starting point that bends to your needs. You're not locked into our feature set. You're inheriting our architecture and extending it with your own ideas. The template gives you the bones. You grow the muscles. This slide might be the most valuable one in the deck. These are the pitfalls we already solved, the ones that would cost you days of confused debugging if you hit them on your own. Pitfall 1, React pinning. Expo SDK 54 requires React 19, 1.0 exactly. If you let pnpm resolve React freely, you can end up with duplicate React instances, one for web, one for mobile, and hooks break, context breaks, everything breaks. The fix, pin React to 19, 1.0 in pnpm.overrides at the workspace root. Done. Pitfall 2, Metro bundler configuration. Metro, the React native bundler, doesn't understand pnpm workspace symlinks out of the box. You need custom Metro config to tell it where to find packages. The template includes the correct configuration. Pitfall 3, Clerk version pinning. Clerk versions after 5, 49.0 on web, and 2.15.0 on mobile, tighten their React peer dependency in a way that conflicts with the Expo React pinning. We pin these versions explicitly. Pitfall 4, the skip pattern. Without passing skip to use query when the user isn't authenticated, you get a flash of stale data or an unauthorized error on component remount. This is subtle and hard to diagnose. Pitfall 5, Tailwind CSS v4 migration. v4 changed how configuration works. It's now CSS native, not JavaScript based. The template is already on v4, one with the correct setup. Pitfall 6, EAS environment variables. Expo's EAS build has its own environment variable system that's separate from your local .env files. The template documents exactly what goes where. Every one of these cost us time. None of them will cost you time. Before we move to the closing section, here are your resources. First, the GitHub repository. This is the source of truth. Clone it, fork it, everything is open source. Second, the Do Me guide, the full 17-phase build process with detailed instructions for every step. If the template is the what, Do Me is the how and why. Third, the documentation, API references, architecture decisions, configuration guides, everything you need to understand, not just how to use the template, but how it works under the hood. And fourth, video content, walkthrough recordings, feature demos, and setup tutorials. If you prefer learning by watching, we've got you covered. I'd encourage everyone to bookmark the GitHub repository. That's your starting point for everything. And if you find a bug or have a feature request, open an issue. This is a living project, and community feedback makes it better. Let's zoom all the way out. This is the full architecture diagram. Everything we've talked about in one view. At the top, two apps, web and mobile. Different UI frameworks, different rendering, different platform conventions, but look at what they share. The shared packages, types, utilities, constants, content form a bridge between them. Below that, the convex backend, real-time queries flowing up to both apps simultaneously, mutations validated by the same schemas, the AI chatbot accessible from both platforms with the same tools and the same rate limits. On the sides, the integrations, clerk authentication issuing JWTs that both apps present to the same backend. File storage handling uploads from both platforms through the same two-step pattern. At the base, the infrastructure, Turborepo orchestrating builds, GitHub Actions running the CI/CD pipeline, Vercel serving the web app, EAS building the mobile app, Convex hosting the backend. For the business audience, this diagram represents a level of architectural coherence that most teams don't achieve until they've been building for a year. With this template, you start here, day one. For the developers, notice how clean the dependency arrows are. Everything flows downward. Apps depend on packages. Packages depend on the backend. The backend depends on nothing above it. No circular dependencies, no tangled imports. Clean architecture from the start. So, why does this approach work? Let me give you three perspectives. For developers, this approach works because it eliminates the busy work. You're not configuring bundlers, you're not debugging authorized token flows, you're not figuring out how to share types between projects. All of that is done. You open the template and you start building features. Your time goes to creating value, not fighting infrastructure. For teams, this approach works because it creates alignment. Everyone is working in the same repository, looking at the same code, using the same patterns. The web developer and the mobile developer share a common architecture vocabulary. Code review is meaningful because reviewers understand the conventions. Onboarding is faster because there's one code base to learn, not two or three. For users, this approach works because it delivers consistency. The features work the same way on web and mobile. The data is always in sync. Dark mode looks right on both platforms. The error handling is graceful everywhere. Users don't care about your architecture, they care about their experience. And this architecture produces a better experience. That's the trifecta. Developer productivity, team alignment, user experience. The template delivers all three because the architecture was designed with all three in mind. Now let's dream a little. What can you build with this? The template is designed to be a starting point, not a destination. Here are 4 directions you could take it. A SaaS application. Strip out the chat feature, add your domain-specific data model, layer in billing with Stripe, and you have a cross-platform SaaS with real-time collaboration built in. The auth system, the real-time backend, the CI/CD pipeline, all of that transfers directly. A social app. The chat and presence features are already there. Add user-to-user connections, a feed algorithm, push notifications, and you have the core of a social platform. The 2-step upload pattern works for any user-generated content. A marketplace. The user profile system becomes seller profiles. The message system becomes buyer-seller conversations. Add a product catalog, a search function, and payment processing, and you're in business. An internal tool. Enterprise teams can use this as a foundation for internal dashboards, admin panels, or team collaboration tools. The auth system maps cleanly to SSO. The real-time features power live dashboards. The mobile app gives your team access from anywhere. The point is this: the template handles the horizontal concerns, auth, real-time data, file uploads, error handling, deployment, CI/CD. You add the vertical, the domain-specific features that make your product unique. That's a dramatically faster path to market for any of these ideas. And that brings us to the end. Let me leave you with this. Building cross-platform applications is hard. It's hard because the platforms are different, the tool chains are different, and the integration surface area is enormous. But it doesn't have to be as hard as it usually is. The Cross-Platform Monorepo Template gives you a tested architecture, a proven build process, and production-grade features, all in one place, all ready to customize. It won't build your product for you, but it will give you a 6-month head start on the foundation. Whether you're a solo developer starting a side project, a startup racing to market, or an enterprise team modernizing your stack, this template is a springboard. Clone it, learn from it, build on it,